Right, well, hi guys, this is our first video, an attempt at sort of making up for the fact you haven't got lessons. This is what we're going to look at today. It follows on from what we were doing last lesson. So last lesson, you were looking at this. You were looking at the risk to coastlines from global warming and sea level change. What we're going to look at today is this. We're going to look at how basically sea level change has basically created different features. So that's what we're going to do. Now, if you're actually going through the PowerPoint, you should be able to play this video just to remind you about isostatic and eustatic change. In this particular video, I'm going to skip this bit, but you can access this through the PowerPoint. I'll try and put a link into Teams and on the YouTube page as well. Right, let's start by looking at this map. So if you look at this map, it shows you basically whether the UK is rising or sinking. If there's a positive number, and it's a red or a yellow or an orange, it's rising. And if it's blue, it's basically sinking. So what I want you to do is stop this video for a couple of minutes and I want you to answer two questions. Can you describe the pattern? And can you explain the pattern? So stop the video now, and in a couple of minutes, when you're ready, press play and we'll talk through what you can see. Okay, well, hopefully what you can see is a pretty obvious pattern. If you look, what you will see is that there is this sort of area here where actually sort of the UK is rising, and as you go further south, what you start to see is that in this sort of area here, the UK is sinking. And now we're talking about a millimetre or two a year, but over thousands of years, that's a metre, tens of thousands of years, tens of metres, so it can be quite substantial. So we've got a situation where Scotland's rising and the south of UK, England, is actually sinking. And particularly, it's worth noticing that Cornwall and Devon are the places which are sinking the most, and we'll come back to that later. In terms of why, this is a classic isostatic sort of rebounding. Scotland had a huge amount of ice, particularly concentrated over that red area. So the weight of that ice pushed the crust down into the mantle flowed, remember it's plastic. It moved from underneath the ice in Scotland, it moved south, it made the UK rise. You take the ice away, Scotland therefore has got less weight on it, so it will start to rise, and England, where the mantle had flown to, that mantle will start flowing back under Scotland and England will start to sink. So that's what's going on there. Okay, so hopefully that's just a recap. Now, there are two key words, so you'll need to stop this video in a second and get these copied down. Basically, where we have a falling sea level, okay, then land is going to emerge from under sea, so we call that an emergent landscape. And conversely, where sea level is rising, which is a majority of the world, but not everywhere at the moment, we have a submergent landscape. Land is being submerged. So just stop the video and get those copied down into your notes for me. Now, what I'm going to do is I'm going to talk through a number of different features. So this first feature is a raised beach. And what you can see here is that this used to be a beach. That's another one over there. So you have a beach, you have a sort of depositional environment, and then suddenly the land goes down. And in fact, you can actually see that the land's gone down and there's been a bit of erosion, there's a bit of a cliff there. But once the sea level has fallen, the land's gone up, that beach can't be eroded anymore, so it's just left there. So that's what we call a raised beach. So that's a sort of classic feature. Now, what we've got here is another raised landform. So this is an emergent landform. And again, a bit like the raised beaches, what you've got here is something that formed at sea level. The sea has dropped, the land has risen. And in this case, what you can see here is you can see you've got cliffs, there's the cliff line, but also you've got sort of caves sort of located here and here. Those caves are formed exactly the same as normal caves would do. It's just that after the cliff and the cave has formed, sea level has fallen or the land has risen. We've got an emergent coastline. Now, this feature is called a Dalmatian Coast. It's probably the most complicated one of all the different features. Now, have a look at the picture. What do you think, emergent or submergent? Well, there's an awful lot of water there, which suggests that basically it was submergent. Now, this formed, okay, with a number of steps. So the first thing that happens is that the rocks are actually compressed. And this is what this diagram over here is trying to show, that basically what happens is the rocks get compressed to form a number of synclines and anticlines. Anticlines are the sort of pointy bits up here. That's an anticline. Yes. And synclines are the dips. Now, what happens is that during the last ice age, sea level is much lower, and so what you end up with is rivers flowing through here. And they will erode those synclines and make them into river valleys. And what you can see over here is that on this sort of diagram over here, you can see they've shown them as the sort of red lines. This is where the rivers were flowing in the past. So they were all rivers flowing in. Now, importantly, these anticlines and synclines, these folds, are running parallel to the coastline. So again, if you look here, here's the sea. That's some blue there. That's all sea. But these anticlines and synclines, they are running like this. These forming here. Now, what happens is that after the ice age, all that ice that's on land melts, goes into the sea, and global sea level starts to rise, and it starts to fill in the land. Now, because we had sort of valleys and hills, the valleys get totally and utterly inundated, they get submerged. But as you can see down here, the tops of those anticlines, the sort of hills, the tops of the valleys, they're above sea level. And so what you end up with is a chain of islands all running parallel next to the coastline. And like I say, this is what a Dalmatian coastline is. It's called Dalmatian because that's the part of the world where it comes from, Croatia. And you may have seen it in Game of Thrones and things like that. But that's a typical submergent coastline. Okay, so here we have another submergent coastline. This is a fjord. And what you'll see in a fjord is a classic U-shaped valley. So if you look at the shape of this valley, incredibly steep-sided, and you can see how it forms a U-shape. Now, U-shaped valleys, they're indicative of glacial valleys. So this was once a river valley. A glacier in the last ice age came along and smashed it to pieces, and that valley, well, as the sea level, at the end of the ice age, the ice melted, sea level rose, and the sea level actually rose to fill the fjords. And again, these are very common in places like Norway and places like New Zealand. Often you actually find that as the fjord enters the sea, it actually gets shallower because that's where the sort of glacier dumped all its stuff. So slightly different from other features we might look at in a second. You've got a sort of shallow bit at the entrance of the fjord and gets deeper as you go in. But basically, again, submergent landform, U-shaped valley formed by glacier, sea level rises and flood set. Now, this is very similar to a fjord, except the difference is here that actually this is a river. So this is a river system that has basically formed during the last ice age. The sea level has risen. Now, these are particularly typical in southern England, where we know that we've got sea level rise quite rapidly. And what you've got is what was once a sort of river. I'll just show you the sort of path of the river. You can see where it's going. Perhaps blue isn't the best colour. Let's try orange. You can see the river was coming here. There's another tributary there. There's another tributary there. Looks like there's another tributary coming up here. So you've got a classic sort of tree-like, we call it dendritic, sort of river pattern. And then what's happened is as the sea level has risen, it's flooded the estuary and gone up the river to form this sort of ria. So like I said, very typical submergent coast form found on the south coast, particularly southwest of the UK. Now, This is perhaps one of the hardest ones to get your head around. This is what's called a barrier island. We're not 100% sure how these formed. What we think is that they may well have represented massive dune systems. You get these in places like Florida, for example. So again, a bit similar to Dalmatian coastline, you had a sort of landform. In this case, there'd be sort of dunes possibly. It would look something like this. And then sea level rises and it sort of floods over most of them, and you get these sort of barrier islands. Now, these are very dynamic environments, so they're constantly being eroded, they're constantly having sand being deposited by longshore drift, and they migrate as well. They're only made of sand, so unlike something like a valley, like a fjord or something like this, these do tend to move and can easily be eroded. So, hurricanes, for example, can quite often destroy them. Okay, so that's enough of the different features. Now, what you'll find on Teams is that you've got a worksheet that looks like this. Okay, well, what I want you to do is simply print it out, or if you prefer, you can use cut and paste. And what you're going to match up is the feature with the photo, the same photos that I've just talked about, with the correct definition. If I give you 10-15 minutes to do that, and then pause the video, when you've got that done, come back to me. Okay, well, I hope you got that worksheet done. It's fairly straightforward, and you have to common sense to go back over the video and answer any ones. Right, just want to talk about what a typical question might be. So you may well get given a photo like this, and you're asked to explain the formation of the features in the photo. 6 marks, okay, and if we have a look at the photo, I've actually labelled it for you, so it shouldn't be that difficult. In the normal one, they probably wouldn't label it, but you can see here, there's Relic, cliffs, caves, and stacks. And over here, there's actually a wave cut platform, a Relic wave cut platform. And again, that's just like a raised beach. It was, except it was formed by erosion. The land's gone up and it's gone there. Now, to answer this question, 6 marks question, what do you need to do? Well, basically, you need to tell me the story. And we're going to focus particularly on these sort of erosional features. So tell me how they formed. I've possibly done it in just enough detail, maybe a little bit more, but notice I've talked about them being erosional features. Okay, I've talked about the features that have formed. So the first part of this is telling me, like I said, it basically just telling the story. Okay, so these they formed an erosion. Then if I'm really doing this exam, I might have mentioned caves in particular formed along lines of weaknesses such as joints and faults and things like that. I've then talked about the second part of this. Let me just change my colour. I've talked about the fact sea level. Now in this case, it's sea level has fallen. Now notice I've used the word relative sea level, okay? Because actually in Scotland, it's more a case that the land has risen faster than sea level has risen. Hence the term relative sea level rise rather than absolute. And I've used that technical term, emergent coastline. And then the third part of this question, I've talked about why that's happened. So I've talked about isostatic sea level rise. You'll notice I've given an example, Scotland. Okay, and again, I've used some technical terms here, isostatic rebound following the last ice age. So I reckon that's easily worth 6 marks. But if you've got a sort of question like that, talk about the initial bit before sea level rises, what was there. Talk about what happens to sea level rise or sea levels fall. Try and use technical words like emergent. Try and use technical words like isostatic or eustatic. Okay, and think of it just a very simple. Tell me the story. So that's me had a go. Okay, now it's your turn. So stop the video again. Give yourself 6 or 7 minutes. Have a go at this. How did a Dalmatian coastline form? If you can't remember, go back in the video, find the bit where I talk through it, look at your notes, and then have a go. So just pause the video now, have a go at it, and then we'll go through it again in a second. Okay, so you can mark this yourself. These are the things I'm looking for. Basically, again, same as before, start the story at the beginning. So it starts with the rocks being compressed, okay, to form a series of folds. And ideally, we're using technical words, anticline and syncline. That's definitely worth 1 mark. The Fjords run parallel to the coastline is important. Rivers flow along the synclines, okay, eroding the valleys. That's certainly worth 1, maybe even 2 marks. Notice I've talked about eustatic sea level rise, okay, and again I've talked at the end of the last ice age. If you want an extra mark, you might talk because ice on land was melting, leading to global sea level rise. And then definitely, I think there's 2 marks here. River valleys flooded by the sea, and that formed a number of islands that run parallel to the coastline. So there's easily 6 marks there. Check that you've got that. If not, use a bit of red pen and improve it. Okay, well, I hope it's been helpful. But good things, unfortunately, must come to an end. But before I leave you, let me give you some homework. So a couple of bits I need you to have a go at. First of all, there's a really good geofact sheet I've put on Teams. Can you please have a good read through that? You can use that to add to your notes. You can talk about the formation of different features, talk about a couple of other features I haven't gone through today as well. But you'll probably want that to have a go at this 20-mark question. And 20-mark question is evaluate. So please remember to box your keyword. And evaluate basically means tell me how important. Okay. And then in terms of key things, change in sea level and the formation of coastal landforms. So what I want to know is how important, okay, what is sea level rise, either emergent or submergent coastlines in the formation of landforms. And this is how I would suggest you do it. So I would start off with a definition, start off by defining what do we mean by sea level rise and coastlines. That's your isostatic, your eustatic, your emergent, submergent coastlines. And then, it doesn't really matter which order you do it in, but I suggest you start with emergent features here. So just start off by talking about how important sea level rise is in emergent features. So you'd be talking about your raised beaches, your cliffs. Try and remember specific examples. You can get those from the sheet I've given you to do, or you can get those from the geofile. Do the same then, when you change your colour because it's a bit dark, the submergent features. When you've done that, okay, you want to give a counterpoint. So can you think of features which have very little to do with sea level change? That might be dunes or spits or arches and stacks that are actually still at sea level. And then finally, you need to give a conclusion. And the question is, how important is sea level rise? And again, key to is when and where is it important? So the obvious answer is that sea level rise is really important in those locations like Scotland, like South West England, like the Dalmatian coastline, where there's been substantial sea level rise. Where there isn't substantial sea level rise, it isn't important. And that's an obvious thing. However, just some other things to think about. Even if we take something like a raised cliff, now you couldn't have a raised cliff or a raised cave if it wasn't for sea level change, but actually they are erosional features to start with. So even here, sea level change is an important part, but not the only part. Same when we're talking about depositional features. Raised beaches, for example, were a depositional feature. So you might want to think about that. If you're really going for it, then tides are actually sea level change. There's sea level change on a twice daily thing, so you could talk about that as well. And again, just to stress, this is an evaluate question. So in the conclusion, and ideally at the end of each paragraph, evaluate. How important is sea level change? Okay, don't leave your evaluation just to the end. Okay, try and do it throughout, but really focus on the conclusion on evaluating. Now, it'll be really helpful when you're submitting this, you submit it through Teams. And what that means is using the Word document that I've given you there and typing this up and sending it to me. If you get stuck, email me. If you want to do a plan and show it to me first, email it to me. I'd also be really interested in any feedback on how this video and Teams is going. So let me know and keep in touch. Right, well, thank you so much. I look forward to hearing from you. Cheers.